In this video, we're going to discuss solutions and their concentrations. So when we're discussing solutions, the compound that is present in the largest amount is the solvent, and the substance present in the least amount, or the substances present in the least amount, are the solute or solutes. And the term that we use to discuss how much solute is dissolved in the solvent is concentration. A solution is defined as a homogeneous mixture. In other words, it's a mixture that appears the same throughout the mixture of two or more substances. You can have mixtures of two solids. Usually when you have mixtures of two solids, those would be, if there are two metals, that would be an alloy. Steel, for instance, is an alloy of iron, where different metals such as chromium and other metals that stop the corrosion of iron are mixed in, and they also will strengthen it. 24-karat gold is an example of pure gold, but 18-karat gold is an alloy where you have other metals mixed into the gold to enhance its robustness. So 24-karat gold is very soft. It wears very easily. 18-karat gold is stronger than 24-karat gold, and 14-karat gold is stronger than 18-karat gold. But 18 and 14-karat gold have less gold in them as the number goes down compared to the other metals in the alloy. And you can also have things like emulsions. Emulsions are when there are at least two of the components of the mixture would not form a homogeneous mixture, but there's a third component that helps the two go together. For instance, if you take the milk straight from the cow, you will not have the fat dissolved in the rest of the milk. The cream will float to the top, so they say. So we add emulsifiers to milk, and if you go to the grocery store and you look at the milk in the dairy department, it will say homogenized milk. And what that means is that they added some emulsifier that allowed the fat and the fat layer and the water layer to go together and dissolve into each other. Another type of mixture, which is a non-homogeneous mixture, is a suspension. And a suspension is not a solution, although often the same types of concentration units are used for a suspension as are used for a solution. A suspension has larger particles, larger solute particles that can settle out over time. And many infant or children's antibiotics actually are made up in suspensions. And so it says to make absolutely sure that you shake the bottle before you measure out your dosage of the medication, and that's because otherwise the solute particles will settle to the bottom of the container, and if you take the liquid off the top, you're not actually getting the correct dose of the antibiotic because the earlier doses will be too low and the ending doses will be too high because all of the medication is still at the bottom of the container. And so if you see that on some type of liquid preparation, even though it may have a concentration that's still in milligrams per 100 mils, it may be a suspension instead of a solution. And the difference is that in a solution, the particles never settle out. They're small enough that they are always mixed evenly into the solvent, whereas in a suspension, the particles are slightly larger and they will settle out over time. Concentration is discussed in several different ways. We can have concentration as weight per weight, and this is usually a percentage. We can discuss this as a weight per volume. We can discuss it as an weight per volume is usually done as parts per 100, or essentially a percentage. So we would usually discuss this as milligrams per milliliter. Or we can discuss it as volume to volume, and this is again usually a percentage. Or what is commonly used in chemistry is molarity, which is moles of solute in 1 liter of solution. While molarity is the most commonly used unit of measure for concentration of chemicals and used mostly in chemistry because it makes solving stoichiometry quite easy, in the medical field, weight to weight percentage and weight to volume percentages are much more commonly used for instance, weight to volume are used for the suspensions of pain relievers and antihistamines that you would give in infant style dosing or for pediatric dosing. A weight per weight percentage might be an IV solution or some other type of solution. But in general, I think most commonly the weight per volume or milligrams per milliliters, or you could say mgs per mil is another way that it's commonly referred to, is by far the most commonly used concentration value, and that's the one we'll discuss most here. So it's important to know that when we're doing a weight to volume concentration, that these are generally used in milligrams of solute to milliliters of solution. So these would be prepared in something where, and usually they're prepared in a volumetric flask, which I don't draw particularly well. And this would have a line on it. And you would put the solid first into the flask, and then you would add your solute first, and then you would add your solvent to maybe not the entire way, and you would stir up the solution, and then you would raise the level to the bottom of the meniscus after all of your solid had dissolved. So it's not that you're taking, let's say, if you have a 10% sodium chloride or salt solution, you would not take 10 grams of sodium chloride and add 100 milliliters of water. You would put 10 grams of sodium chloride in and then add some water, dissolve the sodium chloride, and then dilute up until you hit your meniscus. But it would be the volume of both the sodium chloride and the liquid and the amount of solvent that you added that would give you your total volume. So it'd be 10 grams of sodium chloride versus 100 milliliters of solution. When we're discussing a percentage, so let's say that we have a concentration that is, say, 10% weight per weight, sodium chloride in water. That means that if we assume 100 grams of solution, 10 grams will be sodium chloride. So we would have 10 grams of sodium chloride over the 100 grams of solution which is the sodium chloride, and the water solvent. So a percentage is going to be the parts per 100 parts, whether the part be mass in grams or whether the part be volume in milliliters or liters. Both percentages are going to be put out like this.